Yeah,
All right,
thanks.
so
Oh, sorry, go ahead.
welcome to another knowledge sharing session, everybody. I'm so excited today to have Alex here, who's going to talk about how to improve your prompts automatically. And so I look forward to learning all about it. So, Alex, over to you.
Yeah, thanks a lot, Shekar, for this space to present some interesting ideas that we probably maybe we can incorporate somehow into our product, or we just, to explore better together, gather some experience, right? So probably the title of this talk today is prompt optimization with one of the approach that we have right now on GitHub. I cannot say it's like a standalone product, but it's more like a GitHub tool from Stanford University, created by this university probably. So yeah, I would like just to go through this tool, how we can use it to optimize our prompts. I was, trying to find a way to how to better explain the ideas behind these frameworks. So I created a collab notebook that I'll share right now. Let me do that. And I'll also share my screen as well. So copy link. Let me send it in the chat if you want it. Yeah, let me share my screen.
Can you just drop it in? Oh, I can put it. I'll put it
Yeah.
on the notes anyway. So,
Do you think I need to change the uh, theme to white one or not? It's fine. Is it fine? Is it, I mean, the text is
it looks,
recognizable? Everything's
yeah, it
fine.
looks fine to me.
Okay, team, is it fine for you? Okay, cool. So let's probably start. Yeah, the title is DSPy prompt optimization. And I just decided to put this small preamble to give more overview about the state, what we have right now. So everything that we have right now with GPT models from OpenAI, Claude, from Anthropic, Llama, it all begins, with this paper from Google called "Attention is All You Need." So just if you're very interested in how all these models work, how because sometimes it's really helpful if you know how the model works. The model works, so you probably know how to optimize the prompts, what to expect from the model. So yeah, please read this paper. It's quite interesting. So let's go ahead, right? So the tutorial overview, right? So in this tutorial, I would like to focus primarily on the LLMs, right, on large language models. And one few examples, GPT-4o, Claude models 2.5. And remember, we have so many models, right, from Claude, from Anthropic. So the recent one is Claude 3.7 and some terms, but I see that in this room, everyone from the AI side, so I don't think that we need to explain to go through every term here, but yeah, you can also check them. The main point that when we talk about prompts and about models, usually we also need to talk about data sets, about evaluations. So here's the task. So let's just imagine that we have a task and we would like to implement this task today and just try to optimize the prompt. So the task can look like that. So suppose we need to implement a very basic version of Duo Chat that is able to answer user questions about GitLab documentation just based on the internal knowledge of Claude 3.7. So since everyone is from the AI Foundation group, so when I say based on the internal knowledge of the model, it means no context retrieval step. So we just we give a question to the model and then we get the answer from the model directly. So it's only based on the knowledge that model learned during the training process. And yeah, for simplicity of this tutorial, nothing about AI gateway, Ruby monolith, just some Python code base and that we can run in this notebook, right? So how the typical development process looks like, right? So usually we start with an idea. So this is our task here, right? So for instance, we would like to develop a very simple version of DuoChat, right? So then we select the base model to power our generative AI application. So that's what we have with GitLab. So for instance, let it be Claude 3.7. Usually the next step, we create the prompt and we ask the model to answer the user question, let's say about documentation. So usually the prompt it can look like, you are the best AI assistant that can answer GitLab questions. So please provide your answer following this template. So that's usually what we have, right? And yeah, we call the model. We also sometimes, not sometimes, we implement additional business logic on top, right? So in our case, usually it's something in the Ruby monolith or even in AI gateway. So you get the output from the model, you do something with this output, and you return response back to the user. And usually we also have testing, right? So as with any code feature, like classical one, let's call it like that, generative AI features, they also require tests. Let's call tests evaluations as testing or evaluations. Yeah, because I mean, testing is like an official term, so better to keep using the evaluation term instead of testing, right? And it's very hard to evaluate Gen AI features. So we see that already at GitLab, also some other companies, they experience the same problem. So that's why Langsmith appeared on the market. And it's very hard because, first of all, models, they are non-deterministic. So sometimes you send one input, you send inputs, but you get some outputs. But the next time you do the same call, you can get some other outputs, right? And also because mostly Gen AI features, they outputs generate features that they output some generated text that is hard to assess with classical, equal to methods, right? So that's what usually we have in unit tests, right? In Python, for instance, we use assert statement. So it's hard to do that. So some Gen AI features, for some of them, we can do that. But mostly, let's say, do a chat, do a workflow, we output some code, generated code, test, explanation. So it's really hard to assess with classical methods, just because two different questions, they can be rephrased, right? Versions of the same problem. And yeah, that's why. So probably that's the main goal of the topic. Let's think about that more. And at GitLab right now, so when we build AI features, usually we run end-to-end evaluations, right? For the full feature to check how actual answers the different from the expected ones, right? So right now we do that with GitLab ELI5, which is also prompt library, which is CF. Hopefully one day, I think in a few milestones, it will be just one term, one solid evaluation framework. So we do that, right? And so for instance, we see that we get some evaluation results. And based on these evaluation results, so that's the most interesting thing, we are trying to optimize our feature. And the key word here, I even put it in bold, sorry. We do that somehow, right? We optimize the feature somehow if the evaluation results are bad, and then we repeat the evaluations again, and we optimize somehow. So the thing is that, here I put some issues, right, with this approach, is that the end-to-end tests that we have right now, they cover everything, ML logic, business logic. So it's like, sometimes it's really hard to get the main problem of the bad evaluation results. So it can be because of this chain, right, of this ML logic prompt model call parsing step, or it can be because of their something happened in the Ruby monolith. It's very hard to track right now, right? And we also have an unlimited space of variations when optimizing the prompt. So that's why I said somehow. And for instance, Leslie, she's on this call. We talked about that before. It's very hard to find the optimal prompt just because you have the unlimited number of variations and you don't know which one is the best, right? To solve your given task, right? Yeah, so just to sum up, we have right now end-to-end tests to evaluate the full feature. We also implemented some unit tests to, assess our business logic in isolation, which is great, like a classical engineering approach. But we also need to optimize our prompts and also evaluate them in isolation to better predict their performance. So it's like we have the full feature, we evaluate the full feature, but to better understand the problem of every component, we need to cover every component with some unit tests. And the ML logic, it's also a component that we need just to implement some unit tests and also optimize the prompts. So that's why let's try in this tutorial to mimic some unit tests for the prompt optimization part to avoid, first of all, manual prompt reduction and also to better explore the performance of each prompt, right? So that's the thing that we don't have right now in the company. And sometimes it's really hard to get the reason of having, let's say, bad evaluation results. We also sometimes we don't know what do we need to expect from our prompts, right? I once tried to evaluate our Duo Chat prompt, and I found that we still need some additional post-processing layer on top of the model output. So that's probably we can catch issues like that if we start to evaluate and optimize every prompt in the isolation, right? So first of all, let's try to implement our task. Where's yeah, this one? Let's try to build a very basic version of Duo Chat with LangChain, just because this is our existing GitLab stack. So we just need to install everything. It's already installed. We don't need to repeat this cell, right? Our keys for LangChain Anthropic, it's already there. Let's probably try to run this one just to make sure that the model works as expected, right? So we have an output, right? So from the model, and let's also do the same for Langsmith, right? So we just need to check that we have let's say, a random data set just to make sure that we have a good connection with Langsmith. And yeah, so right now, yeah, the task itself, right? So it's a very simple feature, let's call it like that, if we can do that. So we built the prompt. We say that you're an AI assistant tasked to help answer user questions about GitLab, like a very classical system prompt. Then we say, answer the user question, and this is the placeholder that we can later replace with actual question, right? So this is the output that we expect from the model. We first ask the model to reason about the question. I said answer anyway, to reason about the task. And then we ask the model to generate the actual answer, right? So right now we just need to glue everything together, and we will get the classical LangChain chain, right? That we just need to run with some input data, right? So one of the one interesting thing that I would like to show here, sometimes even in our code base, I see that we have different order of different fields here. And I just would like to tell that it's very important to think about the order of the fields that we ask to generate by the model, right? Because all these models, like Claude, OpenAI, they always predict the next token, right? So you give them some prompts, and they're trying to complete this prompt, generating the next token. So that's why if you put this reasoning field, let's say section, before, you will ask the model first to predict the reason, and then the model will use this reasoning to predict the answer. So if you change the order, it can also it will impact your quality, because you will ask to answer and then to reason, right? Because of this statement of predicting the next token. So that's why ordering is very important. So okay, so we build this chain, and right now let's just implement this chain. Oh, sorry, let's just run this chain for a fake question. Okay, so here's the response, right? I ask what is CI, and we get a response that's, just generated solely based on the model knowledge, no context, nothing. So you can see that based on this prompt again, right? Yeah, and right now, let's just try to generate more examples. We are reading our data from LangChain. This is the data set that we have right now, Duo Chat, context, question, answer, documentation, right? So just ask our model to generate answers for 5 questions. So we can explore this table here, this data set. So it's called like that, examples. So if you can check also the schema of input output. So this is the context, question, target file, the possible answer, so, the interface. Oh, okay, like that. So yeah, and then a possible answer. So that's the data set that we can use in this tutorial, right? Just to experiment with our prompts, with our models. So we send the question, that we get from Lensmeet, right? And we get some answers, right? So here's question, here's the response, right? So that was a question about failed patched background migration in GitLab. So if you're interested in how we generated this data set, you can also contact Eduardo because we worked together on this data set before. There is also a talk recorded somewhere. So outcomes, right? So we build a LangChain pipeline, but we still need to craft the prompt manually, right? So we don't have anything in LangChain that can help us to create prompts automatically somehow, or to optimize these prompts based on some initial versions, right? So again, it's just this snippet. You still need to do a lot of manual work. You need to generate the prompt. You need to select the temperature. So right now we use the default one, right? But as usual, as it happens, in this ML domain, everything that we can automate, we probably need to automate. I don't think that honestly our future is creating these prompts manually. I'm pretty sure we'll get the state where creating these prompts automatically will be our state of the art, and we'll focus more on the logic rather than on crafting prompts and playing with them. Because as I told you before, it's a very hard problem to find an optimal prompt in this data set, in this space of unlimited options, right? So yeah, we build it. And right now, let's try to build exactly the same task, but with another approach that is called DSPy. And so DSPy is just a framework for programming. It was created by Stanford. They say that it's rather than prompting. So it's like they say that it's a framework for programming rather than prompting. So sometimes it looks similar to LangChain. Initially, when I proposed this talk to Shekhar, they had a link between LangChain and DSPy, so it was possible to run DSPy using LangChain. But right now, this link is broken. I checked when I was preparing, for this tutorial. I got this issue. It was hard to understand why. I decided to explore the DSPy repository. I found that they just commented everything related to LangChain in their repositories, and then I found an issue where the authors of DSPy, they said that they would like to create a kind of platform, a kind of tool from their initial approach. So that's why they don't need this LangChain connection right now. Rather, they would like probably to be LangChain, but with just another way to work with your prompts. So yeah, it would be interesting to see what will be their final state. So yeah, right now they have really a lot. If you check their documentation, sometimes it's really clunky, it's hard to get. Sometimes you need to read the code base just to understand the goal of this framework. But the most interesting thing that is quite powerful, and that's not the only one that is focused on optimizing prompts automatically for developers. So there is also some other called TextGrad. So it's quite intense, domain. A lot of frameworks created in this domain. Let's see what will happen after. So, but yeah, I just focused on this one because it was probably one of the first in this domain. So let's probably explore how can we solve the task with DSPy, right? So if we talk about DSPy, we have some core components. So there are a lot of different things, but probably we just need to focus on three main points, like models, signatures, and modules, right? Because they build probably everything in this framework, and you can build almost everything with them, right? Let's go step by step, right? So if we talk about models, so yeah, of course, if you would like to try this tutorial after this talk, you can probably just you just run the cells. Right now, everything is installed, so we can skip it. So let's talk about the models, right? They support Light LLM. I know we love Light LLM. Some team members really love Light LLM, especially in our team, just because for simplicity, for some other stuff. So DSPy supports Light LLM, so it's very easy to connect models. It also supports Llama and SGLang, just if you would like to experiment, for instance, with your local model, it's possible. Just for this tutorial, we focus on Claude 3.7, as I said before, and that's how we can work with the models, right? You just specify the model you want. Based on this prefix, they understand the adapter that they would like to load. So when you say Anthropic, it means that they're going to use the official Anthropic SDK. So Claude 3.7, this line, it configures your LLM for every method that you're going to call later. So it's like you don't need to specify your model when you call the function, rather it's like a global one for all your functions. To be honest, like I don't know is the good approach or not. I would rather prefer to specify my model every time I call a function, just to make the code explicit. Yeah, thanks, Stefan. But I see that this approach is, a lot of developers start to use this approach, especially in light LLM. But to be honest, like I think it's because of the academic nature, right? It sounds very academic. This code sounds very academic. Like let's have one line and you will get your model everywhere across the framework. But anyway, so it's also fine. It can be involved one day, optimized based on the feedback from the community, right? So you configure the model that we can use across the full across your tutorial, right? And also across, let's say, your Python script or Python package. Let's just call it. It looks exactly the same as, I don't know, calling the official Anthropic SDK. You just need to specify the role, you specify the content. So yeah, just specify your messages. But honestly, the way that they propose to work with language models is different. I mean, in DSPy. So they ask to create signatures and modules, right? Signatures, they explain what to expect, and models they just explain how to communicate with LLMs. So if we think about LangChain, it looks quite similar to pydantic-based models that we use in LangChain, for instance, in model with structured output. So when we just create a pydantic model and we specify the output fields, right? And so models, they are quite similar to these LangChain workflows. Like prompt, you create prompt, then you call model with the prompt, then you parse the model output, but it's just all implemented differently using classes, and it's very, very inspired by deep learning frameworks like PyTorch. So I think it's even stated somewhere in their repository. So when you read everything, it looks exactly the same. Even methods like forward, and then you do something, the way that you create, these layers to build your application to work with to work with models. It looks very similar to what we have with PyTorch. So quite interesting approach, right? Let's right now just implement our task with DSPy, right? So here's our question and here's our answer. So instead of Pydantic-based model, we use another base class called DSPy signature. We say that question is our input field, right? And we also say that answer is our output field. It's also a good practice, to provide this docstring, because they use this docstrings in the prompt, so they inject these docstrings into the prompts to help the model better output the expected values, right? And then you just call this line, right? So first you say what, right? What you want to get from the model, sending some input data, and then you just say how, right? So you say that, okay, let's call the predict model, which is just, sending question and asking to return the answer, nothing else. No prompt optimizations like, these reasoning steps when you first ask the model to reason about the task and then you get the answer, nothing like that. So you just give the answer and then you get you give the question and then you give the answer, nothing else, right? So if you see no prompts like with LangChain where you say you're the best assistant, do something with this data, nothing like that. So everything you define with Python code with this signature and model core components, right? So let's just rerun. Yeah, and you get a prediction object with the answer because we ask to generate this answer. So it's like they are trying to guarantee, as well as with Pydantic models, that your output will be as you requested. So in our case, it's the answer field, which is a string, and we return this one. It's quite interesting, to be honest, to see how it works, because with the LangChain approach that I demonstrated above, right? This one, right? Model with structured outputs. So I know we use this method a lot in workflow. I checked the code base, and we use the tools API, right? So which is provided by OpenAI, by Anthropic. So it's like we are creating a tool, which is only a single tool, and we like simulate that the model. We ask the model to call this tool with some arguments. With DSPy, it's different because they inject instructions into the prompt, and they parse the outputs, based on the instructions. It's also fine because it means that it can work with any models that, let's say, don't support tool API, right? Because if we talk about open source models like Llama, Qwen, they don't have tool API. So if you want to create agentic behavior, you need to make sure that your prompt is structured in the way so that we can call, this. So we specify the tools, and then we call them. So it's differently. But to replicate the LangChain example, so just recall we ask the model to reason about the task first. With DSPy, we just need to change our model, right? So in our case, so in case of DSPy, we need to choose this one, chain of thought, and it will make everything for us, injecting this reason about field. So yeah, if we call it, yeah, you will see that. So reasoning, right? So if you check our do a chat answer signature, no fields like that. But when you call this signature with this model, right, you will see that, okay, we get this reasoning field. So that's the exactly so this combination of signature and model, so it looks exactly like our LangChain example above, but implemented differently. But with one difference, we don't work on the prompts manually, right? So prompts created somehow automatically. The default one is created solely by DSPy, right? So the question is how to extract the prompt, how to see really what's happening inside the model, right? Inside the program. So you can use the inspect history method. You can probably inspect all your prompts that you're sending with your program, right? So if we call it, you will see that the default prompt looks like that. So the system message, our question, right? We also have reasoning field and answer. Reasoning field is specified by this model, right? So please recall we don't use any fields like that in our signature. Then we give some instructions how to generate output data. Here is the example, right? So question, what is CI? Respond with these fields, right? This is the response. So that's why I said, right? So we don't use any tool API with DSPy. Rather, they just do everything on their side. So they just inject tools, your output fields using some structure, and then they have some parsers to extract this information from model output, right? So yeah, the thing is, we implemented the task that we had in the beginning, right? And as usual, so first of all, we need to evaluate right now how our feature works. So suppose we have some end-to-end tests, but right now, as I said before, we probably need to evaluate the component that we implement right now. So yeah, we just need to implement the prompts that is automatically created by DSPy. So hopefully DSPy, they provide, some pre-built tools to do that. And so let's just do that. For this example, let's use the real data set that we have right now. It's called do a chat context docs, right? That I demonstrated before in Langsmith. You can find it here. It has the following structure. Let's use this data set. Let's say that so we don't want to evaluate our prompt for the full data set, I think we have over 600 examples, so too many, right? So let's focus on the first 100 examples, right? It's easy, so let's just run this cell, and we will get 100 examples from Lensmith. Here is the example, right? Our inputs, some context. You will also get question and possible answers. So I don't want to scroll. It's a very long one, so you can check it as well. DSPy, they require a format, a very interesting format to run evaluations, to run all optimizations. So we just need to change the schema of our input data set. It's quite easy. You just create DSPy example objects, and you specify that question is your input field. So quite interesting approach. Would be interesting. Do they want to stay with this or not? Because it's like, I'm afraid you still need to do a lot of steps, right? So yeah, you create this DSPy data set, and now we just need to evaluate. So DSPy, they provide a pre-built method. It's a class, right? It's a class called evaluate. You just need to specify the data set that you can use to evaluate your prompt, some basic data like num threads, display properties, display table, just for visibility, nothing else. So the main point is this evaluation data set. So let's just create this evaluation data set. Let's say that we would like to get the first 60 examples from our 100 examples and use them as evaluation data set. So please recall, so when we do evaluations, optimizations, we need to make sure that we don't have the intersection between the data sets used to evaluate and used to train or optimize something. Otherwise, you will get a over fine-tuned model prompt specifically for a set of examples, right? Exactly the same principle as when you train the model. So you train the model on one data set and you evaluate the model on completely another data set. So what DSPy authors, what they propose, when you train the model, usually you say that you take 80% of your data set to train the model and 20% to evaluate the model. DSPy authors, they say differently. So they say, let's use 20% to optimize the prompt and 80% to evaluate, right? So it's like completely different, right? So which is obvious, to be honest. For prompt optimizations, you need less data than to train the model. But to evaluate, you need more data just because it's the main point of your prompts to work as expected, right? Yeah, so you specify your data set. You also need to specify the metric, right? Because when we evaluate something, it's exactly what we have with ELI5. You need to understand according to which criteria you want to be your prompt optimized, right? And there are different metrics that we can implement. So one example, let's say, to use answer exact match, right? So we can run it, honestly. I think everything is cached. Yeah. 60 examples. But if you check the metric, it's zero, right? It's zero, right? So it's no metrics here. So why, right? So I put it even here to the outcome. So the average score is zero, where the maximum is one. And the one means that your program is able to get 100% correct answers. But why we have zero here, right? Just because we choose the wrong evaluation metric, right? So we decided to keep going with answer exact match, which gives one only if two strings are absolutely equal, right? In our case, it's impossible. Just because DuoChat generates some text, this text can be correct. It can answer your question, but comparing to the expected one, it just uses different words. It's different in terms of the way it's written, right? But the semantic logic, or I mean the semantic, the context is correct. So it's like a good example that when we evaluate prompts or when we evaluate features, we need to think about data sets, about the quality of the data sets, and about metrics that we use to evaluate, because we need to make sure that our evaluation results, they are not biased towards data set or evaluation metric. So that's a good example. So that's why, yeah. So let's just try to find another metric that we can use. And we can use semantic F1. And this is exactly the LLM judge that we have in ELF5. So they re-implemented LLM judge, they just call it differently because they have some interesting, let's say, optimizations inside. So that's why, yeah, I decided for this tutorial just to skip, this step of creating your own LLM judge. So let's just use the one that they provide. And we also need to specify a threshold. So we say that if the answer, if the predicted answer has a score more than this value, then it's correct. So I mean, it has the score comparing to the actual one. So this LM judge is pretty simple. You just give the model the expected answer, and you also give the actual one. And you ask the model to treat these values and say what's the value you think they are similar or not. That's why we need this threshold. Yeah, this step is a technical one just because we need to change some data schemas slightly because this semantic F1 they expect response instead of answer, so we can just simply skip it. But yeah, if we run it, it's also fast because it's cached, right? You will see this value. So we say that our evaluation demonstrates that the default prompts of the one that I showed before, it was able to solve the task in this number of percent, right? Across our 60 examples. So not bad, but also not that good, right, for production because we solve less than half of. So we gave good answers for less than half questions, right? But please recall that we use only internal knowledge of the model, nothing else, no context, right? So the thing is that can we improve this performance even having our current setup, right, with DSPy? Yes, we can. I will show you quite interesting results. And DSPy, they provide some methods to do that. So for instance, this optimizer, this optimizer, it can be used both for zero-shot and few-shot prompt optimizations. So I think those who work with DuoChat in the beginning, they remember the difference between zero-shot and few-shot. So zero-shot means we don't have any examples in the prompt, and few-shot means that we have several examples. Sometimes, it helps. Let's focus only on zero-shot, meaning that we just work with instructions. We don't add any examples to the prompt. And the code is, to be honest, quite easy, quite understandable here, but internally not. We just need to create the evaluation set, the train set. Please check that they don't intersect, right? That's a very important thing, just to make sure that our optimization is correct. Hopefully, they provide some pre-built configurations to optimize the prompts. You can say light, medium, or heavy optimizations. We can play with that. So right now, let's just use light, right? Threads, that's a technical one, just to accelerate our optimizations. Yeah, these two examples, they are required. So if you're interested how to add some examples from your data set to the prompt, so you just need to play with these two variables. I put the links to this tutorial so you can read the documentation. It's quite heavy, so that's why I decided to skip it because it's not really important for this tutorial. And yeah, that's it. We don't need to run it right now because these results are not cached. It will take up to 10 minutes probably to get everything, but we can check the logs, right? And if we check the logs, the most interesting part is this one. So step 2, propose instruction candidates. And so yes, and if you start reading these logs, you will see that we have some candidates. So for instance, the first candidate, you're a GitLab technical expert doing something, respond to a question first, do this, do that. There is the second candidate, right? And the most interesting thing, they are all generated automatically without any our manual steps that we need to do. So this optimizer called MiPro, I think it's called like that. It's quite interesting and also quite complicated, but technically it uses LLM to optimize your prompt. It's like you have your default prompt and you ask another LLM, hey, look, this is the data set that we have. These are the results, your evaluation results. Now, please provide some instructions to improve the prompts. That's how it works. So let's say based on this prompt that DSPy creates internally, we create, let's say, 12 candidates. So we create first instructions, then for every instruction, we create, let's say, candidates, and then we run evaluation again, right? We run it again, just trying to find the candidate that can give you the highest score according to your metric. So that's what's happening, overall, like brief overview, what is happening inside the optimizer. And these are the results. So yeah, if you check, so these all are candidates. See, we have a lot of candidates. The step 3, you see finding optimal prompt parameters. So that's exactly the step where we evaluate every candidate based on our data set. So to create instructions, we use the trained data set. To evaluate our candidates, we use the evaluation data set. We don't have this intersection between train and evaluate, so that's why it's quite fair. You can see some evaluation scores here. So candidates 2, this evaluation score, candidate 3, this one. So we have different scores. And yeah, finally we achieved the best score, which is 42%. Not that much, right? Because before we had 39%. But still, the most interesting thing that it's all done automatically based on our data set. We didn't make any manual reductions of your prompt. And it's all done with a very simple approach where you just put your question and expect the answer, no context from GitLab documentation, nothing like that. And yeah, let's check the prompt that was finally selected by the DSPy framework. And this is the prompt, right? We still have this field descriptions in our system message. But the most interesting thing is this one, right? Before it was very simple, just provide the answer. Right now, the prompt is like, you're a GitLab technical expert, specializing in API and in different stuff. And please do this, like first develop, then reason. And that's, to be honest, like what we are doing usually manually, right? When we create our prompts. So sometimes I see that we write exactly the same instructions. Sometimes we do that with Anthropic. Sometimes, we do that manually. Right now, all these instructions, they created by another LLM and then re-evaluated based on our data set. So here is the example for the CI, exactly the same answer. Yeah, the values, right? Not the great difference, to be honest, but please recall it's all done automatically. And let's say if we add some additional context, we will get better results. Yeah, I put some description about this approach. It's too much. We don't need it. Just if you want to read it. Also, it's open source, so that's why there is a link to the paper. If you're interested, please read it. Happy to discuss. And yeah, so first of all, yeah, just going back, you see that authors they say that DSPy is like a framework to program your AI features, something like that. So that's why it means that you can create as many signatures as you want. You can combine them. You can create different models, right? It looks very similar to what we have with LangGraph right now. When we create different nodes, every node can do something. Then we jump between the nodes based on some criteria. That's what we can also do with DSPy, but differently. Honestly, I don't know which approach is better, but yeah, it's quite interesting to see all approaches we have right now in the market, right? So let's say that we would like just to extend our previous program, but when we generate the initial answer, let's also ask the model to reflect on the answer and maybe correct it somehow, right? So that's why we need to create 2 signatures. First, we ask the model to generate the initial answer based on the question. And then we ask to, yeah, please recall, so look, this is the input field, this is the output field. But then we ask the model to reflect on the generated answer. So that's why right now answer is the input field, not output, right? But the output field right now, it's like instructions that we can follow to improve this answer that was previously generated. And right now, this is the correct answer. And that's how we can combine everything right now. So we just need first to generate our initial answer, and then we just pass this answer to the second layer, which is reflect, right? And we get our reflection with some corrected answer. So that in the beginning, I said that this framework looks very similar to PyTorch, and that's where we have it, right? It looks exactly like what we have in PyTorch. We also create different machine model layers, like linear one or something else, and then we combine them. Here we have exactly the same. Yeah, so we can run it. You will get it. But when I try to evaluate the results, I found that results, are not better than with the simple approach. So it means that the main problem is not the reflection, but rather the context. So we don't have enough context to generate good answers. But yeah, so I also put the cell, to optimize this program with reflection. So if you're interested, please run it. I started, but it takes a lot of time because right now, instead of one prompt, we need to optimize 2 prompts. So it also takes time. So yeah. Yeah, probably that's it. Shikar, I think we're out of time. I'm happy to answer questions.
Thanks a lot, Alex. Yeah, I mean, if people got questions, please shoot.
Yeah, I had some questions real quick, if you don't mind.
Yeah, welcome, Leslie.
Yeah, thanks. Yeah, it was really cool. Thanks so much for sharing because this stuff is pretty complicated to just try to read about, to be honest. So appreciate it. And like, I guess I'm wondering if you view like the pros and cons the same as what I do. Because like for me, a pro of this approach would be like maybe people who are non-technical or anyone really could contribute easier to AI features because they could say, okay, here's what I want to put as the input, here's what I want to get as the output, and they don't need to worry about prompt engineering or anything like that. So that's what I see as a pro. But the con is, I feel like we might end up in a situation where we're, let's say someone complains that Duo Chat is not giving the answers they want. We might end up in a situation where we're indirectly trying to influence the prompt. So it's kind of like even worse black box than what we already have with LLMs, which is already a black box. So yeah, I'm just wondering if you would agree with both of those.
Yeah, so one of the things we probably need to prove, it would be interesting, so I'll start like that. So we don't have enough data sets right now to evaluate every prompt that we have right now. So when I was preparing for this talk, I found that probably the one that we have, it's this one that I presented, right, related to documentation, to questions about documentation. Would be interesting to evaluate every prompt that we have right now, just to see, do we actually have any improvements? Do we actually have a difference between what we created manually and what we can, let's say, create automatically? Maybe the difference is very small, so there is no reason right about that. So based on some open source research, and for some tasks, we see that improvement. But you see, yeah, I agree with you. The solution is still quite challenging, right? As I told you before, this tutorial is mainly just to show that the things that we have right now in the domain, not about switching to using DSPy, stuff like that. I don't think it's production ready right now. A lot of things, they still look like academic research, and that's why sometimes they look very complicated. Yeah, so we have this kind of black box. I'm totally agree with you because the prompt is created automatically for you. But the thing is that, can we create this prompt automatically, then copy paste it, then store it somewhere? I don't know. Maybe it's possible also to use an approach like that, right? Like a way to, like, if you have good data sets, why not to try optimize your prompts? Maybe you will get some good results, maybe not. So it's hard to predict, honestly.
Oh yeah, that makes a lot of sense. Yeah, appreciate it. it's really cool to see what's coming.
I had tried a different approach of doing this. Like I don't know what they've done behind the scenes, but I had kind of used like a tree approach to do this, where you
Mhm.
ask the model to like just generate like 5 versions of a prompt, and then you can go to depth n, and basically you pick the like the best version, and then you again ask to generate 5 more versions, and then you keep doing it to like n depth kind of thing. Um, It'd be interesting to see how, like, even when I was trying that, like, I could get like a 2% increase, something like that. Like, I thought it was not worthwhile because of just the
Yeah.
small percentage improvement. Um, and secondly, like the eval data set's also quite small that we have, and so you can't really decide. So I guess have you compared kind of just sticking the prompt into Anthropic and seeing how, or OpenAI or whatever else, and seeing just the suggestion and whether that just causes a 2-3% improvement, or does it really is the kind of the ML quotient of this where it's kind of trying to predict or use whatever Bayesian, whatever they use to sort of improve the candidates, um, whether that actually caused any improvement. Because you could just take this prompt into like the Anthropic prompt improver and say, hey, improve this prompt, right? And so
Mhm.
I'm wondering, like, what is the percentage difference?
That's the thing, to be honest, like that they're trying to use, with this optimizer, but they have one more step, right? So they take good candidates, bad candidates, and based on these candidates, they generate instructions, and then they use
Mhm.
these instructions to almost the same. But the main interesting thing, you see, so they do that. They use LLM to generate as you did, so exactly the same, similar. The only difference that you see they are trying to also to optimize several prompts so like you build a program and they are trying to optimize several prompts. That's
Mhm.
why sometimes the code looks very complicated. It's hard also to debug this code, right? The thing is that the most interesting thing that I see, they don't work with temperature. So they work with instructions, but they don't work with temperature. But I think
Mhm.
that temperature can still also impact
Make a
your
difference.
final quality, right?
Yeah.
And they don't also work with models. So for instance, you have the prompt, you have the task, and you have Anthropic. But let's say that for this task, I don't know, OpenAI works better. So they don't have, you see, this kind of logic to
Mhm.
evaluate also the models, right?
Yeah. So you
Mm,
almost need a matrix of evaluation stuff that it needs to take, and then it needs to kind of run the evals and then figure out which is the
yeah.
best. Then choose
Uh,
the best prompt and then go from there.
Yeah, I think to be honest, like Shakar, the most interesting thing that we probably maybe we need to consider is this evaluate function. But if we start exploring this function, it's exactly what we have with ELI 5 right now. So Alejandro is working on that, and Nadan also is working on that. So we just need to see how our prompt performs. The
Yeah,
optimization part, maybe you're right. Maybe it's just enough to have what you did.
yeah. So I was thinking that if we could run an optimization where we take 3 parameters and we sort of iterate over them, and we have like the model temperature and the prompt, and then we go over different iterations. We generate like 5 candidates to begin with.
Mhm.
Um, and then from those 5 you choose the best one, and then you generate 5 more. Maybe you can take like the best one and the second best one, and then like iterate from there. And then sort of form a tree like that
Yeah,
to decide how to do it.
yeah.
And
We
like
need to.
the transparency aspect that Leslie kind of brought out, like with the tree form, you can actually see the what it decided when, and so you could actually paint that out and see why did it make a decision, for example, and then you could go back and say, oh no, I
Mhm.
wanted to start with this one, and you could probably click on a node above, and then it could regenerate the candidates for that node or something like that. And so um yeah, we could create something like that,
Yeah,
which would
tree search makes
also.
sense. Yeah, it's called Monte Carlo tree search approach, right? It's also used by
Yeah.
one of the approach that solve, SWE benchmark. Yeah, it makes sense. Like you generate candidates. Yeah,
Mhm.
just repeat. You generate candidates. Uh,
And then
you
you
you evaluate
grade
the
them. Yeah.
yes. You also you evaluate the candidate using the LLM, and then let's say you compare the scores of your candidates, you go
Exactly.
with the maximum score, you go to the next iteration, you evaluate again, you get the score, you summarize the score, in this tree.
Exactly.
You go from the root to
I'm
the
having flashbacks to my genetic algorithms class.
yes.
This feels very reminiscent of that. If we're going to do a multivariate optimization, though, we're probably going to need a little, I think Alex nudged it on a couple of times, a little more evaluation data to probably get that really honed in. Because like you can hold two variables fixed and move on a relatively small amount of evaluation data like we're doing here. But if once you start to move through the broader space, that data requirement sort of blows up.
Exactly.
Super
All
cool
right.
idea, though. I love this idea.
We're at time, but it was great. Thank you so much, Alex. This was brilliant.
Yes,
Thank you for actually going through this. Like I was trying to go through the DSPy code. I didn't have the time to kind of actually run this, and seeing you run the thing, it really inspired me. So thank you so much.
Yeah. For the next one, let's try to have really time for Q&A because the debate becomes like a one-way talk. I think if we really put there 20 minutes of Q&A, that's going to be like I had a question and other things to ask, but for other knowledge session, maybe it could be better in the future to have more time for the Q&A. Okay.
This sounds right. You know what, Alpa? If you do have questions, why don't you just put a great suggestion, by the way, and I'll make sure we do that next time. Could you just put your question in the doc, and Alex will try to answer them?
I put it there, but just the sub questions to the initial question went long, so we had 2 minutes. So
yeah.
And we had 2 minutes total, so that's fine. It's just.
Alex, if you could just answer this question offline, that'd be great. And thanks, Alpa. Great suggestion. We'll make sure we do that next time.
Yeah, I'll do that.